Let's practice converting quadratic equation forms, and in particular in this video we're going to practice converting quadratics that are written in standard form to vertex form. And just to refresh your memory before we start, standard form looks like this, where we have y is equal to ax squared plus bx plus c. And then our other form, which is going to be this vertex form, has a slightly different form, but it's just another way of writing quadratic equations or functions. So that's y is equal to a times the quantity of x minus h squared plus k. So two different forms of quadratics or parabolas. Keep in mind that when we're converting from standard form to vertex form, we need to know how to complete the square. If you need a little refresher on that, please check out one of my other videos where I go over that in more detail. Otherwise, let's just go ahead and jump into number 1 and practice doing these together. So we take this equation of y is equal to x squared plus 4x plus 3, and the first thing that we're going to do right away is we are going to just group, so we have the first two terms, the ones that have the variable x in it, and leave the constant on the outside. Now, once we group this, what we're going to do next is we are going to take the same thing that we just have in the previous step, but we're going to leave an extra space here because we need room to complete the square. We're going to have a perfect square inside here in just a moment, okay? So what we do is we take a look at this b term, which is 4, and we take half of it, which is 2. Always take half, and then you square that 2, and you're going to get equal to 4, okay? So we're going to go ahead and add 4 on the inside here. If we add 4, that is the value that completes the square inside here. Now, if we just added 4 on the inside, we need to make sure that we also subtract 4 on the outside, otherwise we've changed this equation, all right? So make sure we do have this plus 4 and minus 4 to balance each other out, so it's not like we really changed the equation, okay? Now, the inside here, this should look familiar. This is a perfect square trinomial, one of your special forms. So what happens is this is going to factor into two identical binomials. The first one is going to be the quantity of x plus 2. And then the second one is always also going to be the exact same as the first one, which makes it a perfect square. Okay, on the outside here, you can see that this positive 3 and negative 4, those are going to combine to make a negative 1. And if you go ahead and condense this just a little bit, you can go ahead and say that if we have two of these x plus 2's, let's just say we have the quantity of x plus 2 and then square it, and then we have this minus 1 on the outside. So this right here would be our vertex form of the quadratic equation that we originally had in standard form. And in this form, we can see that the a value is equal to 1. There's an invisible 1 in the beginning, so there's no vertical compression or stretch. And in terms of the other values, we also know here that we can say that h is equal to negative 2 and that k is equal to negative 1. So remember that we know the vertex of this is going to be at negative 2, negative 1, because h comma k represents the vertex. Let's check out number 2. So for number 2, we have the equation y is equal to x squared plus 6x minus 4. So right away, let's just go ahead and copy down the problem again. Once we copy it down, what we want to do, just like in the last example, is we want to group the first two terms, the ones that have the x value. So let's group it just like that. And then next, I recommend that you just kind of space it out a little bit differently so that we have room to actually complete the square. So right now in the parentheses, we don't have a perfect square yet, but we're going to go ahead and complete that in just a moment, okay? So what we're going to do, just like we did earlier, is we are going to take a look at this b term. The b term is 6. We're going to take half of that 6. If you take half of 6, I'll go ahead and write it like this. Take that 6, take half of it, and then square it. Half of 6 is going to be 3 squared. That's going to equal 9, right? So the value that completes the square here is going to be adding 9. And if we add 9 on the inside, we should subtract 9 on the outside to balance it out. All right, now we've just completed the square, so we should have two identical pieces, right? The two identical pieces, I'm just going to go ahead and open up these binomials just like this. So we should have the quantity of x plus 3 and x plus 3. They're both positive because we had a positive b value. They would both be negative if there was a negative b value. And then this minus 4 minus 9 on the outside combines to make negative 13. Okay, so now we can go ahead and condense this a little bit because we have two of the same binomials. So let's go ahead and open those up, and it's just going to be two of these x plus 3 binomials squared, and then you have this minus 13 that's going to be on the outside. All right, so this right here would be our vertex form of this quadratic equation. Just making sure we understand things about this, we know that a is equal to 1, so no vertical stretch or compression. We know from this that h is equal to a negative 3, and that k is equal to negative 13. So if you wanted to know where the vertex was, the vertex would be at -3, -13 down in quadrant 3. And the AOS would be x equals -3, the x value of the vertex. For number 3, we have this equation y is equal to x squared plus 8x plus 5. I'm going to go ahead and just copy that down. So y is equal to x squared plus 8x and then plus 5. And just like we said earlier, we're going to group the first two terms, the ones with x values, and let's go ahead and space it out so we can actually complete the square. So we have y equals the quantity of x squared plus 8x. Let's go ahead and leave some room so we can actually complete the square. And then we have this plus 5. And let's go ahead and see what completes the square here. So let's look at the b term, which is 8. Let's take that 8, right, and let's cut it in half and then square it. That's going to be the pattern each time. So 8 divided by 2 is 4. 4 squared, that's going to equal 16. So that's the value that completes the square. Let's go ahead and add 16, and let's go ahead and subtract 16. All right, those balance each other out there. All right, so we're going to go ahead and factor this trinomial, which should be two of the same binomials if we did this correctly. So let's go ahead and factor that. It should be two identical ones. And so let's go ahead and see. This should be the quantity of x plus 4. Again, it's plus 4 and plus 4 for both of these because we had a positive 8. And if we take a look at this plus 5 minus 16, that should be -11 on the outside. All right, let's go ahead and condense this just a little bit, clean it up a little bit. So let's see, we have y is equal to quantity of x plus 4 and then squared and then a -11 on the outside. All right, cool. So this right here would be our vertex form for this parabola, which would be the shape of the graph. Keep in mind that there is an invisible 1 in front, so a equals 1, no vertical stretch or compression. In this case, h is equal to -4 and k is equal to -11. So the vertex would be at -4, -11, and the AOS would be at x equals -4, that vertical line. All right, for number 4, we have the equation y is equal to x squared plus 10x minus 6. Let's just go ahead and copy it down and group the first two terms together, just like in the last few examples. Now let's go ahead and just space them out. Alrighty, so we now have this kind of spaced out to help us complete the square. So we have this value of 10, which is our b value. So if b equals 10, let's go ahead and take that 10. Just like in the last few, let's take half of it and then let's go ahead and square it. So half of 10 is going to be 5. 5 squared, that's going to equal 25. So 25 is going to be the value that will complete the square for us. So let's go ahead and write plus 25. But if we write plus 25, we should write minus 25 along the outside as well. All right, so we should be able to take this perfect square trinomial, all right? That's one of our special cases, and then factor that into two identical binomials. So let's go ahead and do that. Each of these should say x plus 5. And then we have these two constant terms here, or just plain numbers, and -6 minus 25 should be -31. Now let's go ahead and condense the two binomials. All right, so we have the quantity of x plus 5 squared. We have two of those. And let's go ahead and take away 31 along the outside. That shifts the whole thing down. And this right here should be our vertex form. Our a value here is going to be 1, so no vertical stretches or shrinks. And then we can see that our h value is -5 and our k value is -31. So it looks like all of these have a vertex in quadrant 3 so far. So -5, -31 would be our vertex. AOS is at x equals -5. Here's number 5. For number 5, we have this equation of y is equal to x squared minus 4x plus 7. Okay, all we got to do first is group the first two. And then let's just go ahead and space it out so we have room to complete the square. All right, so we can see our b term here is going to be -4. So we take this -4, and then we just go ahead and take half of that. Half of -4 should end up being -2. So if we take that -2 and then we square that, that's going to be +4. Don't forget the parentheses, but we should always get a positive here. So we're going to go ahead and write +4 on the inside and then -4 on the outside. Make sure we balance those out. And then we should be able to factor this to get two identical binomials. Notice how b is negative in this problem. So if b is negative, then our two binomials are going to be negative as well. All right, so inside here, we're going to have the quantity of x minus 2 and x minus 2. Right, that way the two negative 2's add to get negative 4, but they still multiply to get to the positive 4. On the outside, the 7 minus 4, that's going to be a positive 3. Condensing this, let's go ahead and write y is equal to quantity of x minus 2 squared, and then write plus 3 on the outside here. All right, there should be our vertex form for this quadratic equation. From this, we know that there's no vertical stretch or compression. We also know the vertex is going to be at 2, 3, and the axis of symmetry is at x equals 2. For number 6, we have this equation y is equal to x squared minus 10x plus 7. Let's go ahead and copy it down, but then just group it up a little bit differently. Let's group the first two terms that have the x value, okay? So let's go ahead and group those. Next, we're going to go ahead and space it out a little bit more. Feel free to skip one of these steps if you feel a little bit more comfortable as you go. I think it just takes a little bit of practice, but I'm trying to just be as thorough as possible here. So let's go ahead and write that, and then write plus 7. And then let's just take a look at that b term of negative 10. So I'm just thinking, okay, take that negative 10, and hopefully you can take half of that, and then square that. Half of negative 10 is negative 5. Keep it in parentheses, because you have to square the negative 5, not the positive 5, and that'll be a positive 25. All right, so let's go ahead and write plus 25 inside, and then write minus 25 outside, so it balances it out, okay? This right here should be a perfect square trinomial if we did this correctly. So we're gonna get y is equal to, and then open up two parentheses here of the same thing, and just double check as you're factoring, this should be x minus 5 and x minus 5. All right, those should be the two binomials. And then if you take a look at this positive 7 minus 25, that should be negative 18. Okay, so we should have y is equal to quantity here of x minus 5 squared. Let's go ahead and write that down. And then minus 18 on the outside. All right, this right here should be our vertex form for this quadratic equation. From this, we see that a is equal to 1, just like it was in standard form. No vertical stretch or compression. The vertex is at 5, negative 18, so we slid 5 units to the right and 18 units down. Those are the translations or transformations. And the vertex is at 5, negative 18 with an AOS of x equals 5. For number 7, we have this equation, y is equal to x squared minus 12x minus 20. So y is equal to, let's go ahead and write this down. And in your head, hopefully you can go ahead and think about like what were the steps that we've been practicing so far. So again, we're gonna go ahead and group these first. If you wanna pause the video and try any of these on your own, I think that would be a pretty helpful thing to try. You know, I'm right here to help along the way, but if you want to see if you can do these on your own, I think that would be helpful as well, right? But whatever works for you is perfectly fine. Let's go ahead and see what would complete the square here. So we have negative 12, right, for our b value. So we take that negative 12, you take half of it, and then we're gonna square it. So half of negative 12 is gonna be negative 6, and negative 6 times negative 6 is gonna equal positive 36. It's always gonna be a positive value that we are putting inside here. And then we're gonna go ahead and put a minus 36 to balance it out. This right here should be a perfect square trinomial. And so we're gonna get y is equal to, and we should have two of these identical binomials. I'm gonna go ahead and put x minus 6 and x minus 6. Again, it should be the square roots of the first term and third term, and then they're negatives because we have a negative 12 as our b term, okay? So we have negative 20, take away 36, that should be negative 56. All right. Now we have two identical binomials. Hopefully this part's getting a little bit easier. And so we're gonna go ahead and write the quantity of x minus 6 squared and then minus 56. Cool, this would be our vertex form of the parabola. Looking at our transformations, there's no vertical stretch or shrink. We move to the right 6 units and move down 56 units. We have an AOS of x equals positive 6 and a vertex of 6, negative 56, down in quadrant 4. Here's number 8. If you want to, go ahead and pause and try this one on your own. I'm going to speed up the process just a little bit here. So here's the equation copied down again. I'm just going to go ahead and group the first two terms. Then you can see I've spaced them out a little bit more so we could actually complete the square. Then take a look at our b value of negative 16. So I'm going to go ahead and take this negative 16. Again, if you can do this in your head, wonderful. But let's take half of it and square it. Half of negative 16 is negative 8. Negative 8 times negative 8 will be positive 64. Okay, so that's the value that's going to complete the square. So let's go ahead and write plus 64 and minus 64. Then we can go ahead and open up these binomials. We should have two identical ones, okay? And let's go ahead and say that should be quantity of x minus 8 times the quantity of x minus 8. And then on the outside here, we have negative 17 minus 64. So I think that's going to be negative 81. Okay, so let's go ahead and write minus 81. And let's go ahead and condense this. We say y is equal to the quantity. And we have this x minus 8. And we're going to go ahead and square that and then write minus 81 along the outside. All right, so this right here should be our vertex form. So from this, we can see that there is no vertical stretch or shrink. We translated 8 units to the right and 81 units down, and we have a vertex of 8, negative 81. Here's number 9. Here's the original equation, and just in your head or go ahead and write it down, try to group those first two, and I'm going to go ahead and space them out, but if you want to just skip that step, go right ahead to spacing them out. Then we're going to go ahead and take this b term of 6, take that 6, take half of it, all right, and then we're going to square it. Half of 6 is going to be 3, 3 squared is going to be 9, so to complete the square, let's go ahead and add 9, and let's go ahead and subtract 9 on the outside. This right here should be a perfect square trinomial, so we should be able to factor it into two binomials. But again, if you want to skip this step and just write the square of the one binomial because you're getting the hang of it, feel free to do so, but I'm just going to go ahead and write it out just to be super clear. And whoever needs to kind of skip ahead, if you're feeling pretty good about this, be my guest. All right, you do you. And then so on the outside here, we're going to have a 9 minus 9 is going to be 0. So I don't know, I'll write plus 0 for now, but you can leave it off if you want to as well. Let's see, y is equal to, and do the quantity of x plus 3. And there's 2 of these, so we're going to square it. And this right here would be our final vertex form, right? So there's just going to be no vertical translation. From this, we can see that there's no vertical stretch or shrink. We had a 3-unit translation to the left and a 0-unit translation up and down. So the vertex is at negative 3, 0. And if you look closely at the original equation that we had, it was already a perfect square trinomial, so you could have just factored and not used completing the square method at all. For number 10, we have this equation y is equal to x squared minus 5x plus 4. This is what it would look like with the first two terms grouped. This is what it would look like with them a little bit more spaced out. Let's go ahead and figure out what this b term is. It's negative 5, so this one's actually going to be a little bit more annoying than the rest. Keep in mind that when b is an odd number, it's a little bit more frustrating to do these. So take this negative 5 and let's take half of it. And after we take half of it, we're going to square it. All right. Now, please make sure you don't use decimals. Let's try to keep everything as fractions, especially improper fractions. So again, this is going to be negative 5 over 2 times negative 5 over 2. And so on top, negative 5 times negative 5 is positive 25. On bottom, 2 times 2 is 4. So this is what we're going to be using to complete the square, 25 fourths. Okay. So let's go ahead and add 25 over 4 on the inside. And let's take away 25 over 4 on the outside. Now this part might be a little bit newer or more difficult just because we have fractions for our constants. So let's go ahead and just open up these binomials. But again, we always have this x and x because they multiply to get x squared. And then we're going to have minus the square root of the c term, which is going to be 5 over 2 and 5 over 2. Okay, so you can go ahead and FOIL this if you want to check to see that this does equal the original. But if you do x times x, x times negative 5 over 2, that's negative 2.5x. That's another negative 2.5x, which does make the negative 5x in the middle. And then negative 5 over 2 times negative 5 over 2 does equal positive 25 over 4. All right, so that does complete the square. Now in terms of this part over here, this might be a little bit annoying to do on the side, but keep in mind that this 4 is the same thing as 16 over 4, right? That equals 4, and we need common denominators. So we're just going ahead and saying, okay, 16 over 4 take away, 25 over 4 is going to be negative 9 over 4, okay? So that's what 4 take away 25 over 4 is. Let's go ahead and write minus 9 over 4. We now have two identical binomials, so we can say y is equal to, and the quantity here is going to be x minus 5 over 2. Let's go ahead and square that, and then take away this 9 over 4. This right here would be the vertex form. From this vertex form, we can see that there was no vertical stretch or compression, that we had a horizontal shift of 5/2 units to the left, or also 2.5 units to the left, and a vertical translation down 9/4 units, or negative 2.25 units, or 2.25 units down. So just looking for some patterns and being aware, if you notice that this b term is an odd number, these are all going to be ones that are a little bit more annoying, so just keep that in mind as you're approaching these ones, that you're going to have to take half of odd numbers, and squaring them, you're going to deal with fractions. So this is one type of problem that usually can be a little bit more difficult, but hopefully these practice problems help you feel a little more comfortable. For number 11, here is our original equation. This is what it would look like if we grouped the first two. Here it is spaced out a little bit more, so it's easier to complete the square. And just identify our b value first. So the b value is going to be 3. Let's go ahead and take half of that. And we're going to go ahead and square it. So again, keep it as improper fractions. This is going to be 3 over 2 multiplied by another 3 over 2. When we multiply, we just get 9 on top and 4 on bottom. So that's the value that will complete the square for us. All right, so let's go ahead and write plus 9 over 4. And then minus 9 over 4. All right, so we now have a perfect square trinomial. So let's go ahead and write our two identical binomials, or the square root of the trinomial, but we have two of them. So the square root of x squared is going to be x and x. And then what's the square root of 9 over 4? Well, the square root of 9 over 4, we just said a moment ago, was 3 over 2, which is just half of b. So it's always going to be the half of b value here. And then here's the little bit extra we have to do with this constant term along the outside. So let's see, this 2, we need to turn into fourths. So that's the same thing as 8/4, take away 9/4. So 8/4 take away 9/4 is going to be negative 1/4. So that's going to be our constant along the outside. Okay, so let's go ahead and write minus 1/4. And let's condense this whole thing. So let's say y is equal to the quantity here of x plus 3 over 2. And let's go ahead and square that, and then write minus 1/4 on the outside. So this right here should be our vertex form. Now just summarizing this with a little bit less writing, so you hopefully get the hang of it and are a little bit more fluent, but the a value here is 1, so there's no vertical stretch or shrink. And we also know that the x value, or the h value rather, of negative 3 over 2 means we shift 3 over 2 units to the left, and the minus 1/4 on the outside means that we shift 1/4 unit down. So that's the vertex, and the AOS would be x equals negative 3 over 2, or negative 1.5, whatever you want to call it. On to number 12. Unfortunately, we have another odd b value, but we know how to handle that. So again, let's go ahead and give this a try. Here's what it looks like if we group just the first two terms. Here it is as it's a little bit more spaced out. Now let's go ahead and actually complete the square. So let's take this value of 7. That's our b value. Let's go ahead and take half of it and then square it. Now half of 7 over 2. Let's go ahead and take 7 over 2 times 7 over 2. 7 times 7 is going to be 49. 2 times 2 is going to equal 4. So that is our completing the square value. So plus 49 over 4. So I'm going to write plus 49 over 4 on the inside and take away 49 over 4 along the outside. For our two binomials, here's what we're going to have. Let's just go ahead and open these up. And on the inside here, let's do x plus the square root of this 49 over 4 is just 7 over 2, or remember, it's just half of the b term, so it's going to be 7 over 2 plus 7 over 2. And then for the constant on the outside, we have to work for this a little bit. So this 4, or this negative 4, in terms of fourths, right? If we times by 4, that would be negative 16 over 4. Take away 49 over 4. So let's see here, it's going to be negative 16 plus negative 49. So I think that's going to be negative 65 over 4. All right, so feel free to pause to think about that for a moment. I think it's going to be negative 65 over 4. Then we can go ahead and condense this. Let's go ahead and say this is y is equal to the quantity here of x plus 7 over 2. Let's go ahead and square that whole thing. And then let's take away the vertical shift or the y value for the vertex. And this right here should be our vertex form. From this, we can see that the vertex is at -7 over 2, comma -65 over 4, which is basically -3.5 and -16.25, I believe. So we have our vertex down in quadrant 3. Alrighty, let's check out the last few here. We have number 13. Let's go check this out. So actually looking back at number 10, I want to go back and just say that I think I made a mistake. I should have put a +5 over 2 for this right over here. So if you just noticed that earlier, I apologize, but I'm just checking as I'm going that I didn't make any silly mistakes. So sorry about that if I confused you, yeah, just double check that part. And I think the rest of them are okay. I'm just actually double checking the rest of them. So I think I did flip them. Maybe you've done that before too. I think the rest of them are okay. All right, so sorry about that. I just wanted to double check my work. These last few are a little bit different. I hope you guys realize that we have A values. If you take a look, these A values are different than 1, so these are gonna be a little bit different. So please pay close attention in case these are types that give you some trouble. All right, so for this one, let's go ahead and just copy the problem down. So we have y is equal to 2x squared plus 8x and then -5. Now, just like usual, we do want to group the first two terms here. We have to do a little bit of extra though. So what we're going to do is we are going to factor out the GCF of these two terms. So we do want the A value inside the parentheses to be 1. So notice how we can factor out a 2 here. And if we do that, we're going to have x squared plus 4x on the inside, and then still leave a gap so that we can complete the square. And then let's go ahead and put a -5. All right, now be very, very careful here, but let's call our B value right now 4, okay? So we take this 4, and let's take half of it. Half of 4 is going to be 2. And so if we go ahead and take 2, and then we square it, that's going to be 4. So that's the value that'll complete the square. So if we put +4 inside here, please be very, very aware that this is not really just a 4 that we added. Remember, there is a 2 on the outside, so when we wrote +4 in here, we really added 2 4s. If we added 2 4s on the inside, we should take away 2 4s on the outside, which is really a -8. So again, yes, this +4 did complete the square, so we have a perfect square trinomial, but because there's this 2 on the outside, remember, this 2 really means that there's 2 of these 4s. So if we added 2 4s, we should take away 2 4s. So just be very, very careful of that. Okay, that's kind of that added level that you want to be aware of if A does not equal 1, which I know is a little bit annoying because it's more work for us. Okay, so let's go ahead and factor this. This is going to be the quantity of x plus 2, quantity of x plus 2, and then on the outside here we have this -5 minus 8, which should just be -13. At least we didn't have to deal with fractions this time, right? So there's that plus. So we have this y is equal to 2 times a quantity. And we'll have this x plus 2 binomial. We have 2 of them because we completed the square, and then -13. All right, so when A doesn't equal 1, when A is bigger than 1, hopefully that rings a bell of what that does, but we do have a vertical stretch here. So from this, we can see that because A is equal to 2, we have a vertical stretch by a factor of 2. We have a horizontal translation 2 units to the left and 13 units down. So our vertex is in quadrant 3 at -2, -13, and the AOS is at x equals -2, that imaginary vertical line. All right, last few here. For number 14, we have this equation y is equal to 2x squared minus 12x plus 3. Notice how A is equal to 2, so this will be slightly more annoying. This is what it would look like if we grouped just the first two terms. Now we really want our A value to be a +1 on the inside, so let's factor out 2 from these two terms. So if we do that, we have 2 times a quantity of x squared minus 6x, and let's leave a gap so we can actually complete the square, and then we have a +3 on the outside. All right, so if we take a look, we can see that our B value is -6. So let's take this -6, let's take half of it. That's nice, it's still a whole number, so we're gonna square that. -6 divided by 2 is -3. Keep that in parentheses. If we square that, that's gonna be a +9. It's always gonna be a positive value. So let's go ahead and write plus 9, and then minus what value on the outside? Well, if you were going to write minus 9, please be careful, right? I know we wrote plus 9 here, but the 2 on the outside is telling us that we really added 2 of those, so that's plus 18. So we really got to write minus 18 along the outside. So hopefully you caught that. If you didn't, just please be careful in the future. All right, so y is equal to 2 times, and we should have 2 identical binomials. Let's go ahead and write those. So we have a minus or a negative b value, negative 6, so we should have x minus 3, x minus 3. That would be the factored form. And then this 3 minus 18. 3 minus 18 should be negative 15. Okay, let's go ahead and condense this. Y equals 2 times the quantity of x minus 3 squared, and then minus 15. This should be our vertex form. From this form, we can see that there is a vertical stretch by a factor of 2. We translated 3 units to the right, 15 units down. We have a vertex at 3, negative 15, and the AOS is at x equals positive 3. All right, last couple, we have 15 and 16. So for 15, let's see what we got going on here. We have y is equal to negative 3x squared plus 12x minus 5. First thing we're gonna wanna do is just write down the problem and then group the first two. And we're going to want to get that a value to be 1 inside the parentheses. So let's go ahead and factor out a negative 3 from this, what we have in the parentheses. So we factor out a negative 3, we should have positive 1x squared. And we're going to have a minus 4x inside here, right? Because a negative 3 times negative 4 is going to be that positive 12. And let's go ahead and keep some space open so we can complete the square and then have this minus 5 on the outside. Now be careful with this one, it's a little bit tricky, so pay close attention. We have this negative 4, let's take that negative 4, which is our b value, and take half of it. If we take half of it and then square it, half of negative 4 is going to be negative 2, and if we square negative 2, that's going to equal positive 4, right? So that's what's going to complete the square. So let's go ahead and put this plus 4 on the inside, but don't write minus 4 on the outside, right? Be careful. This positive 4, how many are there? Well, there's negative 3 of them, so be careful. There's negative 3 times 4, which is negative 12. So this is really a negative 12 that's being added in here, right? That we've put in this negative 12. So make sure on the outside, we actually put positive 12. So pause to really think about that or re-listen to that, just rewind a little bit. But yes, we did complete the square with this positive 4. But this negative 3 on the outside really told us that we really kind of contributed a negative 12 here. So to balance out that negative 12, we need to put a positive 12 out here. So there's a lot of flipping and some strange things maybe going on there. But if you think about it, hopefully that negative 12 and positive 12 cancel each other out. Okay, we can go ahead and open up these binomials, and we should have 2 of the same ones. So we have x minus 2 and x minus 2. And then on the outside here, we have a negative 5 plus 12, and that should be a positive 7. Okay, so if we go ahead and go a little further, we can condense this and say this is going to be the quantity of x minus 2 squared, and then we're going to add 7 on the outside. All right, so this right here should be our vertex form. From vertex form, we can see that we had a vertical stretch by a factor of 3. We had a reflection across the x-axis because a was negative. We had a horizontal translation 2 units to the right and a vertical translation 7 units up. The axis of symmetry is at x equals positive 2. That's an imaginary vertical line at x equals 2. And our vertex is at 2, 7. Alrighty, final problem, number 16. Let's check it out. Here's our original equation, and we've grouped the first 2 terms here. Let's go ahead and factor out. Now, if you're gonna say to me, oh, you can't factor this, I know what you're saying, but we technically can factor this, so this one's a little bit more annoying, so maybe extra credit if you can kind of understand what's going on here. So we're gonna factor out a 2 anyway. We're just gonna have to have a fraction in here. So it kind of goes against what you may have done in the past a little bit, but this does happen sometimes. So if you can do this, that's you pretty much can do any of these, right? So let's go ahead and factor out the 2. Now, if you factor out a 2 from 5 and you're like, 5 divided by 2, that should be just negative 5 over 2, right? In terms of what that's going to be. Let's go ahead and end that parentheses, leave some space for completing the square. But if you're wondering if this does check out, 2 times this x squared is 2x squared, and 2 times this negative 5 over 2 does equal negative 5, just because those 2's will cross cancel, Okay, so I know it's a little bit strange here, but this is how it would work. Okay, now it's a little bit also interesting that this b value is a fraction, right? So if we take a look at this, we can say, okay, we have -5/2, that's b, right? And if you're gonna take half of that, then you have to divide it by 2, right? And then we're gonna have to square this whole thing. But keep in mind that when we divide it by 2, we really multiply, we keep change flip, multiply by the reciprocal. So that's gonna be times 1/2. Now, -5/2 times 1/2, that's going to equal -5/4, right? And if we square that, that's going to be +25/16. Okay, so -5 times -5, +25, 4 times 4 is 16. So this is the value that will complete the square for us. So +25/16. All right, +25/16. I know this is not the friendliest problem. Not only that, but if you go ahead and write -25/16, that is not going to be what we're looking for. Not only that, we don't want to write -25/16, so take a look here. We just added 25/16, but how many of them did we add? We added 2 of them. We added 2 of these 25/16. So what's 2 of those? 25/16 times 2, right, is really the same thing as adding 25/8, right? 25/8 is double of 25/16. So if we just added 25/8 on the inside, we should take away 25/8 on the outside. Let's go ahead and write -25/8. Okay, all right, I know this one's a lot. Feel free to pause to think about it, pause to rewind and try it again. But at this point, I think we've completed the square. We just have to keep going and turn it into vertex form completely. So we're gonna have 2 of these binomials as usual, and the square roots of x squared is just gonna be x and x. B is negative, so we know we have minus minus. And what's the square root of 25/16? That's gonna be 5/4 and 5/4. Now, if you really wanna pause to FOIL it out, you can say x times x is x squared, that checks out. X times -5/4 is -5/4, and another -5/4, that's going to be -10/4, but -10/4 is the same thing as -5/2. And then finally, -5/4 times -5/4 is +25/16. So everything does check out. Now, this is also frustrating, a little bit more work for us to do, but let's go ahead and see here. 4 is the same thing as 32/8. That's what 4 is. We're taking away 25/8. So 32/8, take away 25/8 should be 7/8. Not the worst one we could have done. So let's go ahead and write +7/8. I think we're almost done. We have y equals 2 times the quantity here of x minus 5/2, x minus, 5/4, sorry, I said 5/2. And that's going to be this whole thing squared, and then +7/8. Alrighty, so let's go ahead and put a box around this. This would be our vertex form. From this, we can see that we have a vertical stretch by a factor of 2, a horizontal translation of 5/4 units or 1 1/4 units to the right, and a vertical translation up 7/8 of a unit. So our vertex is at 5/4, 7/8, 5/4, 7/8, and our vertex is located in quadrant 1. And we have a axis of symmetry of x equals 1 1/4. So that's our imaginary vertical line that kind of splits our parabola in half. So there you have 16 different practice problems where we converted standard form of quadratics into vertex form, which gives you some different information and tells you more about the transformations, as well as the vertex, and graphing may be a little bit easier. Okay. Again, if you need to find the blank PDF or blank worksheet for this, or the answer key PDF, if you'd like that, it's in the description box below. Feel free to download those or make a copy as needed. And as always, keep up the great work that you're already doing, and I'll see you in the next one.